Hi, welcome back to Python 5 Part 2. I'm going to be covering arrays and accessing arrays in this video. In the last video, we covered slicing, so you should have an understanding of that now. And we're going to use that again in this video. So let's hop into Jupyter and begin. Here we are, back where we left off. That's where we were before. And now we're on to Numpy arrays. So what is an array? An array is another word for a matrix from mathematics. Arrays are similar to lists, in that they hold ordered data and can be indexed and sliced to access entries. We use the numpy function np.array to create an array out of a pre-existing data structure. To create an array, we can only pass a single data structure as an input to numpy.array. So let's see a working example on creating an array and then explain what's going on. So we're going to begin with importing numpy. I'm going to make two lists here as an example, and I'm going to make an array. That's an array. This is what an array looks like when you print it out in Python. Now, it's time to explain what exactly is going on in order to make this array. Some of the functions are self-explanatory once you think about them a wee bit and once they're kind of explained. So I'll begin with the zip function here. The zip function pairs entries in two data structures together in tuples. So one limitation of this function that you should know about is that the data structures must be the same length. An example of using zip is to combine a list of x values and a list of y values together to make coordinate tuples. Okay, so if I can explain this in terms of indexes, I have two lists. Okay, I've got two lists, and I want to put certain entries together. I want to put the index zeros together. I want to put the index ones together, index twos, threes, and so on and so forth. You can have as long of a list as you want, and you can put it into zip and it will work. What zip does is it returns an object, effectively. Python calls it a zip object. The zip object is basically tuples. So the first tuple, which is going to be index 0, will combine all the index zeros from the lists that you have inputted. Okay, and you can put in as many lists as you like to zip, and it will zip them up in a tuple, and all the index zeros will be together in a single tuple, and then all the index ones will be together in the index 1 tuple, and all the index 2s and all the index 3s and so on and so forth, and you'll have a massive data structure. But the important thing is that certain entries will be now in a single data structure combined. And this is what we want for making arrays, because arrays have rows and they've got columns. So we zip our lists together, and this is it, so we can make a single data structure effectively. And then when I do this here, when I zip x and y, these two lists, I've zipped them together, and I've got a zip object now. I can't view it. It's no good to me. I can't put it in. It's not a data structure. But it does exist, and I can transform it. I can change it into a list. And I can use a function that will make a list for me out of this object. And the function is just called a list. And we can put in our zip object, and this is what we get out. This is what I was describing. We've got a list here, and it's a list of tuples, okay? And in our list, index 0 in the list is a tuple, and all the index zeros from the lists are in this tuple. So index 0 tuple contains index 0 from the lists. That makes sense? So all the zeros are linked together. All the ones are linked together in index 1. All the index 2s are linked together in index 2. You can have as large tuples as you want. There could be 5 things in these tuples. There could be, 100. And the list can be as long as you want as well. So now we've taken two lists, two separate data structures, and they're now represented in a single data structure. And we've shown how they're connected as well. These are coordinates. We've got x and we've got y, and we can make a point out of this. So the point 0, 1. And this is what I've got here. From zipping it up, we've got the point 0, 1. These are coordinates, and they're also going to be rows as well. And we're going to see how we can make them into rows. So we've got a single data structure that numpy.array will understand and convert to an array for us. Let's save the structure in a variable and pass it to numpy.array. We could also just input the expression of creating the list and zipped object, as this is equally valid without saving it to a variable, but we're just going to save it to a variable to make it slightly more clear what's going on. So in this line here, we're going to first zip up x and y lists zip up the entries in tuples in here with this zip function. And then zip can take as many lists as you want to combine. And then we're going to convert that zip object to a list. We can print it out. Here is the object at the top, and down below is the array. So we've taken this object, this list object data structure, saved it into DS, which stands for data set. And then we printed it out, or I've printed it out to show you. And then we've used numpy.array on the data set, so a single data structure. And then we've assigned that to the variable r, which is short for array. And then I've printed out the array here. So you can see every tuple is a row in your array. And then down below we've got 0, 1, the first tuple, and then 1, 2, the second tuple, and so on and so forth. So every entry in the list is a new row, and the separate entries in the tuples represent the columns. So the first entry in a tuple is the first column. Okay, see that? So 0, 1, 2, 3, 4. This is the first column in here. And then likewise for the second entry up to 5, you can see that's the second column in here. And we can use indexes to reference these rows and columns in exactly the same way as we index lists. So we begin with row 0, and it goes down row 1, row 2, row 3, row 4. And we also have, now we have the extra thing, we have columns. So we can index columns as well. So column 0, column 1, column 2, column 3, and so on and so forth. So arrays are made up of rows and columns, as I've just shown you. Rows go across horizontally, and columns go down vertically. Indexing arrays, it follows the syntax, so the name of the array, and then square brackets, same as slicing, same as indexing. You enter the row index, and then a comma, and then the column index. And it goes rows first, and then columns. Rows first, and then columns, okay? Where row and column is the position number of a particular row or column. And then the layout for the position numbers of rows and columns I'm going to show you in this array here. So each tuple is a row, and then each entry in the tuple is an entry in a column. So these are the indexes of certain rows and columns. So you can see here, if you look at it down the ways, this is column 0, this is column 1, this is column 2, column 3. If you look at it across the ways, which I really should have done first, is row 0, row 1, row 2, row 3, and I've entered zeros in the rest of it just to make it a bit easy. So first we're just going to access a row. We can just leave out the column parameter. Just row 1, give me row 1. What's row 1 going to be? Well, it's going to start with 1, and the rest are going to be zeros. Hopefully that works. There it is right there. I've not printed it out either. I've just asked for Jupyter to just show me the value. There it is. That only really works if you don't have any other code to execute in that, or you end your code with just this statement here. Jupyter will just show you what's in it, what value it holds. That's it here. This is the second row. There it is there. I've just entered the row index first, no column, because I just want to access the row. So remember, we've got two operations to perform. We've got indexing and we've got slicing as well. We can use both. Slicing can take place to access a selection of rows. So say I want to see rows, the second one and the third one. Show me them. So here we go. We've got that row that we just saw, this one here, and the third row as well. And again, it's exclusive of the stop index. So index 3 is the last row. It's not been shown here. It's exclusive as well. So now we're going to access a column entry too, because it's going to be more useful when we have columns of data that we want to access, say time data or temperature data, or I don't know what else you would call it, like position data. So to begin, we'll just access a single entry in a row and column. So we've got the positions array, and we also refer to the dimensions of an array as well. We call this a 4x4 array. It's got 4 rows and 4 columns. It's rows first and then columns. The array up here is going to be a 5x2 array. 5 rows, 2 columns, 5x2. So we've got positions, a 4x4. We want to access just a single entry. So 0, 0, that's going to be the 0th row, the 0th column. And at the intersection point there, when we're indexing, is going to be the entry that's going to be printed out. And in this case, it's just 0. And then we've got positions. This is row 3, the bottom row. And then column 0, the first entry in that row. And I've already executed it. And here we get 3. So it's this one down here, 3. So when you're indexing in both row and column, then what it effectively is the intersection. That's what it is. You go, right, row this one, column this one. That entry, print that out. That's what's happening there. So the rest of that is just, it's using a different array. It's using the 5x2. We're looking at the first row, second column, it's 1. The fifth row with 4, so down here. And then index 1, second column, 5. Okay, so that's indexing. So now, this is the important bit. This is what you're going to be using. This is going to be really helpful for you. You want to access multiple rows. You want to access multiple columns especially. You're going to use slicing. That's why I taught you that in part 1. See, it was going to come back in part 2. So in a list, if we want to access several entries in the list, then we slice it. In an array, if we want to access multiple rows or multiple columns, then we also use slicing. So we can print good old positions just for the demonstration of this. So first, I want to access the first column. So arrays are organized by rows first and foremost. You know, we've got our rows here. You can see they've got separate brackets around them. It's just how they're displayed though. So if we want to access a column, we first have to go through the rows, and then we want to select which entry in those rows do we want to show. So we do a full copy of all the rows in our slice. And then this will access every row for us. And then we want to index a column position in the column's entry. And then this operation specifies what you want to see from the array. The slice says we want to see all rows, and the index says we want column position 1. This is the second column. So when I do this, I'm first printing out a full copy. So you can see here, rather than a single slice operation, because I've got rows and columns I can access, each individually, you know, with indexing and slicing, we can have 2 slice operations now. So you can perform indexing on the rows, slicing on the columns, or slicing on the rows, indexing on the columns, or, you know, slicing on both, indexing on both. You've got the full variety of operations to perform now. So first off, I've made a copy. This character here is a new line character. Don't worry about that. It's just to put a space between each one. So here, this is me accessing a column. This one here, this is accessing a full column, the first column. I'm saying, I want to see every row. Every row, give me every row, okay? And now, show me the first entry in all those rows. The first entry in all those rows. That's a column. What this operation returns is a new array, okay, and it's laid out horizontally. But what it actually is all of these entries that go down the way. It's returned the column. It's just displaying it horizontally as if it were a row, but it's not. What we've taken is a whole column by accessing all of the rows and then going, I want to see this specific entry from the column. Now, what you could do is you could perform a slice and you could see 2 columns at once. But if you have separate data in separate columns, that's not so useful to you. So usually you will want to access a single column for one set of data, your time data, your position data, your temperature data, voltage, whatever it is. That's what you're going to use in labs. This is why we use arrays, because they're very useful. You just tell them what you want it to show you, and then it'll do the rest of the work. So in this one, I'm showing you that these 2 operations are actually identical. So accessing a row and then asking for all the column entries is the same as just asking for a whole row. I mean, it is, isn't it? If you go, I want to see this row, but show me all the column entries with a slice, that's the same as just indexing that row. So as you can see down here, these are identical. That's all there is to indexing and slicing arrays, and also creating them as well. This is the end of part 2. Thank you very much for watching. In the next video, we're going to be covering how to plot a line of best fit and the use of the gradient as well in graphs. It'll be a very important video. It's going to be very useful for your experimental labs. I hope you find it interesting as well. So I will see you then. Bye.